Hello everyone, I'm Silent Death, and welcome back to a Stationeers No Mining Challenge. Last time, we hooked up our auto keeping stock system to our auto smelting system, which is hooked up to our ore storage system, and so we can, automatically smelt stuff as to keep things in stock. This episode, we have this little vending machine here that has all of our stuff that we're trading for, and it's got 98 out of 100 items in it. It is taking hours and hours and hours of my time to constantly unload this and organize everything and stick it where it goes and all that kind of stuff. So what we want to do this episode is automate that process and, have things go just, automatically unload in a few things. But first, before we talk about that a little bit more, we want to make some changes, or just a minor change to what we did last episode. So what I would like to do is change it so that when we're manually crafting something, our ore request or ingot request thing will trigger if we don't have enough stuff. And that's going to be fairly simple. The only thing that we need to do is, one, we need to turn on that reagent IC, whatever we call that chip over there. And as long as there's only one machine on, it will locate that machine and see what it's trying to craft. And if it doesn't have enough stuff, it will send the request. But if that machine was the last thing that that had something crafted, if it already has the stuff in it, then the export count, it will read the export count, and it won't trigger if the export count is greater than 0. So what we need to do is we need to change it so that when we push one of these buttons, it clears the memory. If you remember last episode, we edited this so that it did not clear the memory when it moved the ingots through, so that we didn't produce more than a stack. But now it will do so. All we have to do is find our laptop. And this is going to be super simple. So we're just going to come down here where we commented out that line right here. And where we have the buttons, so button press. Right here, before we click on anything, we'll just set this. And that's all we have to do. Piece of cake. We'll confirm that. And then we need to have a way to turn that chip outside on. And we can do that. We could just go outside and turn it on, but yeah, that's not convenient until we have our doorway here and pressurize that whole area. That's just really inconvenient for me. Don't want to have to go through the airlock to do that. So what we're going to do is we're going to use something I haven't ever used before, which is one of these logic switches. So let's see, I think just putting it, kind of in between these two. We'll put it on the same, level as the buttons. That looks fine. We can just click on that. And hook that up to that over there. And I think having it over here between these two, because either two I'm more likely to use, is where I want it. So we just need to wire that up a little bit. And we're going to need to assign the screws, which means we'll need to have a wall on the other side so that we can tear that wall off. This should be pretty simple. There's a data input, a data output, and there's power on the other side. And then we already have the wire right there. So yeah, we can just wire that up really quickly. And that's all there is to it. Then we'll just stick a wall here so that we can access the screws from the other side. And it's set to the reagent IC housing and the on variable for that. So that'll turn that on and off. And the problem I'm thinking is it may turn it back off if that is changed from another setting. So let's go check that. Okay, that does not seem to be a worry. It does not go anywhere. It seems to only change things when we flip the switch. So if we click here, it's on. That should turn it on. Really wish airlocks were faster. And yep, it's on. It's flashing an error because we don't have any machines on for it to turn on. Alright, so that is that. Now we'll move on to today's primary topic. So just to talk about how we're going to set this up. The first and most important thing is going to be the gas canisters. The exploded gas canisters are frequently exploded gas canisters when we buy them from the gas trader and they're shoved full 300 moles. We want those to be taken out of here extremely quickly, like check every tick or every second or something like that. I think we only have maybe 20 seconds before they explode, 20 to 30 seconds. And we want to send them somewhere to be emptied. We already know how to empty the gas canisters because we've been doing that all along by sending them to a recycler. But I checked off camera and that does not work with water canisters. However, water canisters don't explode, so it's not a big deal. We do need to come up with a way to automatically empty water canisters. There is liquid drains, which I think I have some. Liquid drains, which is basically the liquid version of a passive vent. But it's still, if you put a liquid canister in the recycler, it does not spill out the liquid. I don't know if you can spill out the liquid anymore. You used to be able to, but they may have changed it, or it may just be that the recycler hasn't been updated to, or when the water got turned from a gas into a liquid, they just didn't ever update that code. So it could be either of those. Either way, it doesn't matter for us. It just means we need another way to get the water out. The next thing is we have ore ingots, which we already have an ore storage set up, so we want that to go out there. And we have the ingots in our manufacturing area. We can just send those right into the machines. Those we want to be sent out not every second, not as high priority as the canisters, but we want them to be sent out like frequently. Then there's everything else, which, you know, like the various other stuff that's not part of the things. We want those to be not sent out as soon as they're put in the machine, but sent out when the machine starts to get full or when we actually tell it to send them out. So we'll have a manual switch to empty it, or it will check the quantity thing, and when it starts to get full, it'll empty things out. We want to do things that way because we want to stack the various, you know, whatevers, the various kits and things, so that they stack together before being sent off to vending machines or whatever, to our other storage area, depending on which place they go. And the first thing we're going to do is try to figure out where we're going to handle the gases and water. Oh, that means we're going to need a big giant place to process everything. So to start with, we need to frame in this whole area out here where the edge of our base is going to go. And we need to roof in this area over here where our Amy area is. And here we are. So this wall here is the edge of our Amy room and our storage room down below. This wall here is the edge of our storage room up above and should be the edge of the pressurized area of our base, or maybe this won't be pressurized. We're not entirely certain how we're going to do things there. But I'm thinking that we'll only have this area here for the Amy's and wall off something like this. Then we still have the entrance from this hallway into here. And we'll have this wall for other displays that we're going to need when we expand this area. Some of these will probably need to be rollover covers, but we can change that in a little bit once we get around to it. And the benefit of that means that we can put the whole recycle thing like in here. It shouldn't take up too much room. I think maybe a 3x2 would be plenty of room. And it would have access to the vertical shaft from our elevators. Then on the other side of this wall here, we can add the water. Because I was planning on putting the food and water storage in here somewhere. I was originally going to put it over here in this corner, but that was before we moved this guy here, because we were going to originally have the door here into our fabricate area, but we moved it over here. That means we would either have to put it like right here or something like that, but this corner here looks best. And I want to use a corner locker for that. I just like the way they look. It doesn't have as much stuff, but we can also fit maybe some shelves or something. A shelving unit would work. Maybe one of the upper shelves like this would also work. Something like that. We could have a shelf and then our water thing somewhere underneath it. That would look good too. A medium shelf. An overhead locker. Or short locker. I think a shelf. Just have like a shelf right here between the two lights. And that like there. That should be, a fair amount of food. We could have more shelves and more stuff if we wanted to. So let's look at here. We're going to want an airlock because this room is going to have the pressure from all the gases in it. And do we want to do the full 3x3 or just go 3x2? I mean, 3x2 is plenty of room unless we account for the airlock. We could do... I think we're going to want the airlock maybe right here. Just do that. Maybe seal off the area, something like this. Or we could just do this. That might be enough room. We'll have to come back once we build some more stuff out and see how that looks. But I think this will probably be enough. It's only if this wall is going to be in the way. We do the water here and the gases over here. That should be fine. And then that'll have access to the chute network for the reagents from the recycler can go down into the ore chute network. And the liquid and gas can go into our maintenance tunnel under here via the elevator shaft. I think that'll work quite well. As for chutes, we already know what color we're going to do for the chutes. We're going to have red for priority. The red's priority for the gas canisters are going to be red. The ingots are going to be gray. We already have khaki for the production. That just means we need to pick a color for the storage room, which I think we'll just go with white for that. Probably. We're using white somewhere else though, aren't we? And I don't remember where. Somewhere. Where did we use white? I can't remember. I'm pretty sure we used white. Was it inside? It was inside here, wasn't it? So yeah, no, not white. Not black and not brown. Not green. Could do something like purple, maybe. Anyway, we'll pick a color, we'll lay the chutes, and then we'll use spray paint to paint it later. What we'll do is we'll have let's see. The ingots are going to go this way as the khaki chute. The stuff that's inside the vending machine right there is going to go both right in this direction and get sent off that way. Then we'll have the ore come over here on the outside. So it'll be something like ore will be right here. Then next to that we will have the canisters. And beside that, we'll have the storage room stuff. That's going to take up most of the space in this little area here. It's going to take quite a lot of chutes. Good thing we have the auto smelting thing to smelt all of our iron cores, because this is going to take a lot of chutes. Holy crap, this is going to take a lot. That should be those three. And there's a few things we want to check before we do that. Let me get that set up for a moment. Okay, the first thing I wanted to check was if gas canisters count as liquid canisters. There's a category for liquid canisters, but I want to see if they go through the same thing. So we just need a couple of canisters. You go out that side. And you do not. Okay. So those do not cross, or those do not count the same. Now the other thing, which is kind of the most important thing, is if we look at a vending machine, it has this little request hash thing. And it tells you that when set to the unique identifier, it requests an item of the provided type from the device. So what I'm wondering is, can we use the categories to request a category of item like ore or canisters instead of the actual item hash? Even if there is, you know, there's really only 2 item hashes that we have to worry about for the canisters. But if I could do the whole category for ore and stuff, that would be so much easier. So what we're going to do is we've set this up to the vending machine, and we have code here to request the hash for gas canisters and liquid canisters with a 2-second delay between them. And nothing happened. So what if request this? Just to make sure that we're doing it right. And it appears we're not doing it right. Something is wrong there. Let me look into this a little bit more. Okay, so it's even worse than I feared. It specifically wants liquid canister water, which is the trade good canister and not the generic liquid canister. So it's going to have to, we're going to have to do this canister for volatiles, pollutants, and all the various gases individually, instead of just doing the one generic canister. That is going to be a pain in the butt. A major pain in the butt. But that kind of solves one problem, and we figured out, I think we figured out something here. Which side the canister goes from. There's a CO2 canister, that'll do. It is on the side opposite the power. Alright, I always forget that. I wish there was like a marker or something on this. You know, this side says filtered, because you know there's no little highlight thing if you point over it. Yep, it just doesn't say. It doesn't say at all. Alright, so that is what we're going to do. Under here, I've started working on getting chutes connected up. So we got the ingot chute and the product chute for the things that go in the vending machine. And we're going to have to set up some sorters underneath this. So the first sorter is, of course, going to be the canisters. The gas canisters and the liquid canisters. So that'll be, we'll set that up programmatically. It's really just going to be hard to cram everything in here. It was opposite the power. Opposite the power. Opposite the power. Okay, so have you come through? This is going to be really inconvenient, isn't it? Might be better if we do it this way. And have it come around. That might work a little bit better for that one. Then this one, we'll just loop around like this. The filter will go out that way, so we could have this stuff on that one. And then the other ones will just be like this, and then filter out in a set of series, something like that. Yeah, that looks good to me. This will come through. And really, it's only this one. This one is really the only important one that really matters. Alright, that one actually goes up. It's the most important one. The other ones, we don't really care if they're efficient or not, as long as they get done. This one. If I can actually get here to place it. This is going to be inconvenient. that'll be the red one, which goes in the middle, we decided. And then the other stuff's going to be kind of, well, we'll figure it out. I will be back. Alright, so we've got the canister sorter, the keep in stock vending machine sorter, then the ingot sorter, and finally, this is the ore sorter, which is not spray painted because I missed it. There's also a stacker. Let's see, right there on the unfiltered, which I think that's wrong. I made a mistake. No, that's the ore filter. Yeah, those are backwards, but I'll fix that. Okay, good thing that I colored things so that I can spot the ears like that. So there's that. Then these run along here, down through. See, they split. Black goes there. And that heads down to the ore storage room. Then purple goes over here. And just spits out into the middle of our storage room. And red comes over through here. In this place, we are going to have a sorter. Let's make sure that we can connect a wire to this. We can, okay, no problems. Was worried that the elevator would collide with it. So, I have figured out how to deal with the liquid, the water. And let's see, we're going to do that here. A furnace. A furnace works. You don't even have to turn it on or anything. You just need a furnace. And you don't get anything out of it, which is the downside. But everything else, you know, that's pretty good. Looks like this way is going to be best. With iron, wrench, so that way water will come through and into there. We could use this for everything, but we wouldn't get any iron because you don't get the resources from the canister. The canister just gets flat out deleted, and the resources end up in here somehow. So we'll have a connection here. This will connect to the various networks. However, we're going to power this, I don't know. We are completely out of wire colors, so we need to figure out some way to do this. Maybe a, like, dash dot thing, I don't know. We'll do something like that, and then the recycler can connect to wherever. Okay, the recycler does not connect like I thought it did. This will be fine. That's where the recycler will connect. We might want to move it out so that it doesn't collide with the thing in the next room. So it's not poking through the wall. Yeah, it does need to move out. But having it like right here in the center, so, you know, one more over would work. that's a little bit in the way of our walking. Okay, so we can get around into this area here. And like right here is where we'll put the programming stuff. And over here is where we'll put a vent. Yeah, I think that'll work fine. We can have it powered from that line. Yeah, look, that sounds good to me. So we'll need a rollover cover thing. The doors are there. I think we're just going to do kind of simple doors here. Like, I don't know, glass or something. Depends on what fits. So, composite rollover cover. My favorite door of all time. Because it makes things so neat. So this will be where we'll have a sensor to detect the pressure and other stuff, and our programming chip, which is going to be a fairly simple program. This, we can finish this up a little bit. We don't need to do things like we were doing. If I can reach in there. Anyway, we'll wire that up. And so this will have a chute that'll come out and connect to the ingots over there. And then this output, how are we going to do that? That's going to be a little bit complicated. It probably is going to have to go down and around. But it needs to be insulated for one. We can let the water cool in here until we reach the desired temperature. But until we get to, until we get our atmospheric whole thing set up and decide how we're going to cool things, I'm not going to worry about cooling this for the time being. We'll program it so that it has that option, but when we're setting it up, we'll just use it like 20 degrees, which is the default canister pressure. So it shouldn't be a big deal. Means we don't need this wall. Now this fit in a 3x1, or if you don't count the airlock. And that is, so this is where we're going to have the water canister. And yeah, I think that'll work fine. So let me place some more stuff and I'll be back. Okay, we've got the furnace. Oh, the water comes out to here with the volume pump, and then it splits. This will go to our water bottle filler with a valve so that we can shut it off and empty out the pipe and move it around if we need to. Then we have the active vent to pump out the room. The recycler with the chute going off and down that way. Then we'll have IC chip here. We have a gas sensor. And we don't have enough wires to finish the airlock, so we'll probably just use a manual airlock for now. And if we go down, or we should go this way. So this comes out, that splits. One is going to go up to the greenhouse area and everything up here, which I did not hook up. Then we have the insulated liquid pipe and the insulated gas pipe run off this way. And they come around here with another couple of shutoffs. The water is cut off because we don't have that much of it. But the gas, we're using the pipes for the storage, just the volume of the pipes for storage, since I don't have tanks and stuff hooked up to this. So we switch to regular pipes here. We're just worrying about this heat transferring with the atmosphere that's going to be in that vertical shaft. So this comes through here. We'll have another shut off here in case I need to move things. And then this just ends right here. It's hopefully enough. I mean, you can fit quite a lot of gas in a bunch of pipe like that. So, since we're out of wire, the vendor, or the trader, the trader has some copper, and I want to trade with it, but we can't fit it in this thing. So we want to do that. We're going to start with the script for this. Setting up the various sorters. So we did batch sorter, turn them on, set them to mode 1, then this is water canisters and gas canisters and something else. And then we did all the stuff that goes in our keeping stock system. And then just a loop here for this. So we're using the negative number with the relative branch to loop this up to here and stick all those in. Then I think that's OR. And then we're turning off the sorters and turning ourselves off. Just a quick little setup to save me from having to do stuff. So that's this. Fairly straightforward. Now, we're going to want a switch. As we said earlier, we're going to want a manual switch, which will be a toggle switch, because that can be reset with the script. And we don't have any wire, so we'll just disconnect this guy. Okay. So what we want to happen is we want it to check every whatever. Basically, every time it does something, it's going to check to see if there's any gas canisters in here. And if there are, it's going to try to get them all out. So what we need is we need to go through here. And take all these hashes from this canister thing and check each and every single one of them. That is going to be super annoying, but that is what we have to do. The water we don't have to worry about. It can be just filtered out with regular stuff. Probably we may want to filter it out, but that is what we'll have to have a push thing. We'll push all those hashes onto the stack, and then we'll have a function thing that will be called whenever something else is done. Yes, that is what we'll start with. Okay, let's see what we've got here. So we've got the maximum quantity is how many items it can have before it automatically empties. Then we have the hashes. This is the category or the classes for ore and ingots. Then the various hashes for the canisters. So we initialize the stacker settings to 500. And we save the stack pointer into RSP. We turn on the sorters and the stackers. And we read the setting from the switch. If the switch is on, we empty. Then we read the quantity. If the quantity is above the max quantity, we go to empty as well, which I've disabled because we're over this line and I don't want it to automatically empty. I'm going to check this part first. So this part goes down to ore and ingots, which is below this, which sets the index at the first storage slot and immediately goes to request canisters. Request canisters loads the quantity, then it peeks at the hash. It sends or sets the request hash to the hash that it loaded from the stack, waits a tick, then it reads the request hash to see if it actually gets set. I think, but I'm not sure, that you cannot set the request hash for something that isn't there. I'm not sure if that's true or not. Either way, this won't break anything. But if it's equal to 0, it skips this sleep statement. So this allows it to run, theoretically, it allows it to run faster if there's no items. Otherwise, it gives it plenty of time for the canisters to get that out. Then we save the quantity into old quantity and reread the quantity again. We're checking to see if any items have been spat out. And if they have, we skip the subtracting from the stack pointer. Basically, this part means that if it requested an item and it was sent out, it's going to keep requesting that item because there might be more than one. Then if the stack pointer is not to 0, it goes back to a big loop. And if it is 0, it resets the stack pointer to our stack pointer and returns. Then back down here, this is fairly simple. We're reading the class from the slot, our index.
Oxygen critical. Low pressure.
And if the slot or if the class matches or our ingots, we go to request. Request just reads the hash, the occupant hash from that slot, and sends a request to the vending machine, and then waits 2 seconds for returning. Then after that, we add 1 to the index. If the index is greater than max slot, we return to main. Otherwise, we keep looping. So that's that whole little loop there. Then empty is down here where we set the switch to closed. And then we're doing the same kind of loop here, except for we're doing the same check to see if we requested an item. So we're loading a request for every single slot. So this would be 0 if there's nothing in there. Then we're checking the quantity. If the quantity has decreased, or if it's changed at all, it will go back and request that again and again. See right here. Yeah, I think that's right. It may not work properly. I'm not sure if that actually works properly, because that item would not still be there. Maybe. It depends on how it does. What I want is it to request all items from at the same time, all the items of the type from all slots at the same time, so that they will end up in the stackers and stack together and then get spat out. And I don't think that this does what I want it to do. So I need to fix this. Additionally, there's one more thing we want to do, which is we don't want to run this all the time. What we want to do is we're going to use a proximity sensor. And I'll just put this like right here, because it won't take any extra wire. And what we'll do is we'll have a batch, something another, not a batch, but a logic writer thing. So I'll figure out how we're going to place this, which we'll figure out somehow. It's something like this. And that's a logic reader, not a logic writer. The logic writer, which is going to read, hopefully there's a setting for that. Setting is 2. Wait, no, that's not what we want. We want quantity. So we might need a writer and a reader. So I don't think we can set this properly. Let's see. Give me my stuff. we're out of things. That's going to be a little bit of a problem. Okay, so can you... Writer switch. It's not even picking this up. The proximity sensor. Should be in alphabetical order. It's not showing, even though this has a setting, it should be able to read that. Okay. So we'll need a logic reader and a logic writer. So you will read whatever setting that is, probably active. Like active. Activate. So proximity sensor, variable, activate. And now we need some more wiring, so I need to find somewhere where I can scavenge some wire, and I'll be right back. Okay, so we've got these two set up. Now this will control the power for our IC housing. But we do not want this to shut off if it's in the middle of something. We want it to finish what it's doing, then shut off. So what we're going to do is we'll use the chip to turn off these two. And then when this goes off, it'll check it in the main loop. So that when this goes off, it'll turn these two back on, which will also turn it off. But after it's done with the loop. And that should work like I want, so let me do that. Okay, we have the proxy sensor, the reader, and the writer. Then we read the activate setting and set that to R on off. Then we either turn on and off the sorters and the stackers. Then we not R on off. And we turn on or off the reader and writer. And that rest of this is the same except for down here. So what I did is we're no longer using this part, but we're doing that part ourselves. So we're doing that, loading the quantity, requesting the hash, sleeping, reading the quantity, checking the quantity, and right here we're doing a negative relative jump up to this line if they're not equal. And then the rest just goes on like it was. So that allows that to loop through there. And I think that'll work exactly how we want. So theoretically, if I turn on these two, this should turn on this, which should turn them off, and then start requesting stuff. You may have to back up out of range. There that goes, turn them off. And this is requesting canisters like mad. Another canister, another canister. All kinds of canisters being requested. I'm not sure how you can tell. I guess if we hooked up a console with a hash display, we might be able to figure that out quickly enough, but they seem to be flashing through there just as fast. That seems to be getting rid of the canisters pretty quickly. We're already down like 20-something items. But the easiest way to check that is to look at the sky. So we've gotten most of the canisters gone. One thing I'm noting is we may want to change the order because right now we have Water is the first one we request because it's the last one I typed in. So I probably want to move water to the top up here instead of the bottom. That way we'll request the gases first. That makes more sense to me. Alright, so I think it's through with that part. And yep, it was just shoving it out there. That should be that much. And it should be taking care of this ingots and ores, so we can actually trade with this guy, because now we have room. Alright, no, we'll take some solder, sure. We could take the uranium, it's not like we need it for anything. We could take the charcoal as well. Electrum, Hastoy, nickel. Take some nickel, coal, and definitely the copper. Firm. And you can leave now. No, we'll leave you here so that we can watch this work. Alright, so we still have do the room in here now that we have some copper. So let's do that really quick. This shouldn't take a couple minutes. Okay, we wired this up to the same network as the satellite dishes are on and the vending machine, so that if the vending machine is on, this is on, that should work. And this script is not very long, so we've got a vent, active vent, a gas sensor, a furnace, sorter, recycler, and a liquid volume pump. Then on pressure in those, then we have a delay, because I don't want to check the pressure of the room as often as I'm checking the recycler thing. It doesn't need to happen as frequently, and this will save us a little bit of performance. So we are checking if slot 0 of the sorter is occupied and saving that to R on off. And if it's occupied, we're turning on the sorter. If it's not occupied, it turns off. We did the same thing with the recycler. And then we're adding 1 to our count. If our count is less than our delay here, it loops back to main. And otherwise, it moves down here. Our count is reset to 0. Then we're reading the room pressure. And if the room pressure is greater than 0, we're setting our on off to 1. Otherwise, it's 0. And we're turning on or off the vent. Then we're doing the same thing by reading the pressure in the furnace. If that's greater than 0, we're turning the liquid volume pump on or off. And loop back to main. So super simple. We should be able to just turn this on. There goes this little guy. That's on. Oh, we forgot one thing. Let's define setting to 10. Then set the pump setting to this. So that's still off. That should not still be off. The pressure is getting kind of high in here, and you're also off. If something is going on here, maybe that did not... There it goes, okay. Is this going the right way? I'm surprised the room hasn't blown open. Why is this not... Okay, I guess it's pumping as fast as it can. I thought these only go up to like a couple... This should only go up to like 100. Oh, it's It is breaking. It just has it completely broken. That's one problem we might have. Maybe I want to turn down that, and that's probably just that I dumped a whole bunch of it in the same time. Or we could do a bigger room. Either of those would work. But that's going to be it for this episode. We'll think about that between episodes. That was really kind of close. Need some duct tape. Like if you like, subscribe if you're not. Thanks for watching, and I will see you next time.